Alright, this is 11.5, factoring by greatest common factor, which we will call the GCF. This is always what we will do first whenever we factor. So first of all, what is a factor? Well, a factor is any polynomial that divides evenly into a larger polynomial. Alright, so it's any polynomial. It could be just a number, it could have variables with exponents, but any polynomial that divides evenly into a larger polynomial. So here's an example. What are the factors of this product? 6x squared y times x minus 2 times 2x minus 5. What you may initially think is start distributing everything. But actually what we're going to be doing is doing the reverse of distributing in this process. So for now we're just looking at the factors. Well, what are the factors of 6x squared y? We have 6, x squared, and y. Those are each factors. We also have x minus 2, that's a factor, and 2x minus 5 is a factor. Well, what about x squared? What are the factors of x squared? They are x and x, because x times x is x squared. Then we still have all of these other factors. So here's just an example of what factors can look like. They can be in parentheses, be numbers, or variables. So there are two methods for finding the greatest common factor. The first one is a factor tree. So here's how we find a factor tree. We're going to do the prime factorization of each term. We're going to find the shared prime factors and then multiply the factors together. For example, we want to find the factors, the greatest common factor for 36 and 54. The way we start that is look at 36 and we ask, what can we multiply to get 36? Well, to get 36, I can multiply 6 and 6. But can I go further with either of these? Yes, with 6, what can I multiply to get 6? I can multiply 3 and 2. Now, whenever we reach prime numbers, that means that that stem is finished. So circle whenever we have prime numbers. Well, what about 6? What can I multiply to get 6? Again, 2 and 3. I reached my prime numbers, so I circle them and I'm done. So we do the factor tree of 36. Now the factor tree of 54. What can I multiply to get 54? One option is 2 and 27. Well, 2, that's a prime number. We can't break that down anymore. But what about 27? What can I multiply to get 27? That's going to be 3 and 9. 3 is prime, so we'll circle it. Is 9 prime? No, it's not. What can I multiply to get 9? That's going to be 3 and 3, which are both prime. So we circle them. Now that all of the ones at the end are circled, we know we're finished, and what we need to find is what do they share? What are the shared factors of 36 and 54? Well, I see a 2 here and a 2 here, so they share a 2. I see a 3 here and a 3 here, so they share a 3. And I see another 3 and another 3, so they actually share a second 3. They share 2 and 3 and 3. So that's step 2, finding the shared prime factors. Now our GCF, to get that, we just multiply these together. 2 times 3 gives me 18. So my GCF of 36 and 54 is 18. Let's try one with variables. What if we have 8x squared y and 24x cubed y? We need to find the factors of the number and of the variables. So first 8. What can we multiply to get 8? We can multiply 2 and 4. Well, 2 is prime, so we circle it. 4, we can go further, and that's 2 and 2. So those are my prime factors. Now x, what does x mean? Or x squared mean? X squared means x and x. And then, of course, y just means y. All right, so now 24. Let's look at those factors. What can I multiply to get 24? I could multiply 6 and 4. Well, neither of those are perfect squares, so we need, I'm sorry, I misspoke. Neither of these are prime, So we need to go further. 6. What can I multiply to get 6? That's 2 and 3. So those are both prime, so we circle them. What about 4? To get 4, I multiply 2 and 2. So those are prime, and I circle them. Well, what does x cubed mean? X cubed means x times x times x. And y, again, just means y. All right, now that we did our factor trees for both of these, we need to find what is shared. That's step 2. Well, I see a 2 here and a 2 here, so they share a 2. And I see another 2 for the 8, another 2 for 24, so they share another. And yet another 2 shared with another 2. Let's look at the variables. They share 1, 2 x's. So x and x. And then, I'm going to mark those out. And then what about our y's? They both have one y, so they share 1. Okay? So they share 3 2's, 2 x's, and a y. Now we just need to multiply these together. Well, 2 times 2 times 2 gives me 8. X times x gives me x squared, and then y. So the GCF of 8x squared y and 24x cubed y is 8x squared y. Let's look at method 2. So that's the first one, factor tree. What if we don't want to do the factor tree? If not, then we can list the factors. So that's method 2, listing the factors. So first thing we do is list all the factors of each term, and then we find the largest factor that they all have in common, that all terms have in common. So here's an example, 18 and 27. Well, for 18, we're just going to start listing the factors. And the way that I would encourage you to do this is start with 1 and just work your way up, 2, 3, 4, etc. So 1 times what is 18? Well, 1 times 18 is 18. Now we ask ourselves, does 2 go into 18? Yes. 2 times what? It's 2 times 9. Does 3 go into 18? Yes. How many times? 6. So 3 times 6 is 18. Does 4 go into 18? No. Does 5 go into 18? No. Does 6? Yes. We actually just looped around. So the way I approach this is start at 1 and then go 2, 3, etc. until you loop around to this number, and then you know you're done. If you just choose numbers randomly, then you won't know when you're finished. But if you do it systematically, then you will. And we know we're done there. So those are the factors of 18. 27, we start with 1. 1 times 27 is 27. Does 2 go into 27? No. Does 3 go in? Yes. 3 times what? 3 times 9. Does 4 go into 27? No. Does 5? Nope. Does 6, 7, or 8? None of those go into 27. So now we're at 9, and we've looped around. Now I know I went through that kind of quickly, so if you need to put in your calculator 27 divided by 4, 27 divided by 5, that's okay. You can take it slower if you need to. So now we have our factors of 18 and 27. The next thing we need to do is just figure out what they share. Well, they share a 1, of course, but what's the biggest thing that they share? They share a 3, but 9 is the greatest common factor. GCF, again, stands for greatest common factor. Let's do one more. We have 15x squared y squared and 4x y squared. Let's start with just the factors of the numbers, and then we'll talk about the variables. 15. We always start with 1 times that number. Now we ask, does 2 go into 15? No. Does 3 go into 15? Yes. And 3 times 5 is 15. What about 4? No, 4 doesn't go into 15. 5? Well, we just looped around because we went to 5. X squared means x times x. Y squared means y times y. All right, now the next one. 4. Of course, we start with 1 times 4. Now we ask, does 2 go into 4? Yes, it does. 2 times 2. And obviously, we looped around here, so we don't have to ask about 3 or 5 or 7 or anything else because we went ahead and looped around. So now we have x and we have y times y. Now we need to find what they have in common, the greatest things that they have in common. First, look at the numbers. I see 1, 3, 2, 5, 4, 15. The only thing they share in terms of numbers is 1. What about with variables? I see an x on this side and an x on this side. And then with y's, 2 y's here, 2 y's here. So they share 1x and 2 y's. So what's the GCF of this one? We have 1x, and then y times y is y squared. Do we really need to write the 1 there? No, we can just write it as x, y squared, and that is our GCF. Now that we know how to find the greatest common factor, the GCF, now we need to figure out how does it work to factor with that. How do we factor using the GCF? Well, what is factoring itself? Factoring is unmultiplying. It's unmultiplying. So we are going to be undoing the distributive property. Well, we know how to use the distributive property. If I gave you this problem, 2 times x minus 3, what would you do? You take the 2 and give it to the x and give it to the negative 3. You distribute it, and that gives us 2x minus 6. What we're doing with factoring is we're taking a problem like 3x minus 12, and we are writing it in this form. We're trying to figure out what number did we distribute and what did we originally have in parentheses. This number we distributed is our GCF. So when we look at this, we have to ask ourselves, what can I take out of 3x? What can I take out of 12? That's our GCF. That's what we distributed. So let's start with an example. Number 1, we are going to look at 4x squared plus 6x. We want to factor this. So first thing we always look for is the GCF. Well, to find the GCF, we can start with our factor tree, or you can list the factors. I'm going to use factor tree on this one. So let's start with 4. 4, we can multiply 2 times 2 to get 4. These are both prime, so I'll circle them. Now the x squared. X squared means x times x. Let's go to 6. What are the factors of 6? We can multiply 2 times 3 to get 6. Those are both prime. And then, of course, x is just x. So now I have my factor tree of both terms, and I need to ask myself, what do they have in common? What's the greatest common factor? Well, they both have a 2. Then they both have an x. So what is my greatest common factor here? They both have a 2, they both have an x, so it's 2x. And then what I want you to do next is write down the original problem, and we are going to divide both terms by the GCF, by 2x. Because ultimately, what we're doing when we unmultiply is we're taking that GCF out of both of those. Take it out of 4x squared, take it out of 6x, and that will tell us what ends up being in those parentheses. Because remember, I mentioned up here, whatever we can take out is the GCF. It goes out front. So now on this problem, in our answer we'll have 2x, that's our GCF. Well, what's left over? 4 divided by 2 gives me 2. X squared divided by x, we have to think of top heavy or bottom heavy. That's top heavy, and what do we do with those exponents? We subtract them. So we're going to have x to the 2 minus 1. That leaves us with x. Plus 6x divided by 2x. Well, 6 divided by 2 gives me 3. And x divided by x, they cancel. So now in my parentheses, I have 2x plus 3. This is what we originally distributed to get this answer. So we just unmultiplied. One note here, whenever we're talking about the x squared and dividing, if you ever have one that's bottom heavy, that means you took out too many x's and that your GCF is incorrect, okay? So we should always have them top heavy. All right, answer the questions on the video notes and then head to the next video.